Emulsions and gels, two different dosage forms, but I think you're going to see that they're related. Essentially, your gel is going to be kind of a micro emulsion. So that's why it's best to kind of start off with emulsions. And I really, frankly, would wish we could have covered this a little bit before the creams and the ointments, because if you remember, some of your bases last week and the week before actually were emulsions. We talked about oil and water and oil emulsion type bases. So a lot of semi-solids are emulsions as well. So, but then we're going to focus today in terms of the emulsions. We're going to be doing an oral emulsion. An emulsion is essentially when you mix an oil and a water, right? You need to mix them together. So I thought the best way to maybe illustrate why are we making your dry lab prescription. So look in your packet. If you look in your packet, the first prescription you have there for the dry lab is for, I don't want to mess up his name. Who was the patient's name? Sawyer, right? I think it was Sawyer. I'm flipping here. I'm not doing a good job. All right, for the delay. Mark Sawyer. I should remember that. Mark Sawyer, what does he need? Therapeutic agent is mineral oil, right? Oh, wait a minute. Mineral oil. I thought that was a levigating agent. It is a levigating agent, but it is also therapeutically used. Did you realize, some of you know that you have mineral oil in your pharmacy? You sell it in bottles. Do you know what aisle it's down, what it's grouped with? It's a laxative. It helps with constipation. Basically, if something gets stuck in there, it helps it slide out, all right? So it's very effective for that. So do you sell a lot of it? Does everyone want to come in and use mineral oil for their laxative? And the answer is probably no. It's very effective, but why? Why wouldn't you just normally want to take 2 tablespoons of mineral oil? Well, let's watch this video. Now, the video that shows you here is a brief little thing from the Little Rascals, but this is castor oil. But I think the girl in this little video, I think, does a good job of describing why you're making what we're making for the dry lab prescription. So let's see if this works. I should have clicked it earlier.
Not going to have a bunch of sick children on my hands.
Uh-oh, here it comes.
Come on, line up.
Well, at least we're at the end of the line. Yeah. Maybe it'll run out before she gets to us.
About! Hey!
Open your mouth. Open your mouth. Open. Stop it.
I think this expression says it all. So there are a lot of therapeutic oils. Let's not watch it again, for heaven's sake. All right, there are a lot of medicines that come as oils that are therapeutic that cause a lot of beneficial effects. But oils, especially taken orally, taste terrible. They have a bad taste. They have a weird texture. It kind of coats the mouth. It doesn't come away easy. It leaves a residue on the tongue. So it's kind of disgusting. So a lot of people don't like medicines that are kind of oil-based. So if you look on your dry lab prescription, we're going to take this mineral oil from Mark and essentially make it yummy because we're going to mix it with cherry syrup, because who doesn't love cherry syrup? However, the problem is mineral oil is an oil and cherry syrup is a water-based flavored vehicle, and they don't mix, right? Water and oil don't mix. Or do they? You as a pharmacist can say, oh, I can mix those for you. All we need to do is add an emulsifier, because an emulsifier is a chemical. It's a essentially structure that has a hydrophilic head and a hydrophobic hydrophilic head, hydrophobic tail, or lipophilic tail, so that it orients and can hold part of the water next to the oil and hold it together, okay, and make it essentially mix. I didn't do a great job with that, I'm sorry. So the point is, when you guys do make emulsions, flavored emulsions, if you will, do you want the water to be dispersed in the oil, or do you want the oil dispersed in the water? So keep in mind, emulsifiers don't make the oil and the water mix at a molecular level. What it does is it disperses in very small droplets, one of the phases in the other. And it's why emulsions become cloudy. If you think about water and oils, they're often clear or translucent by themselves, but when you make an emulsion and shake them up, they become cloudy. Why? Because inside of one of those phases is the other phase in the form of these really small droplets. Now, they're so small that you can't see them, but there's so many of them that they make the emulsion opaque or cloudy so that you can't see it. Well, the point to what type of emulsion you want depends on the amounts and the types of emulsifiers. So if you want the water to be dispersed in the oil, or conversely in the dry lab prescription that you want, we want the oil, the gross tasting part, to be dispersed within the good tasting part, which is the watered cherry syrup. So we want an oil in water for your dry lab prescription, for example. And so what you're going to see here, making these things is a piece of cake, but the calculations and the formulation take a little bit of time so that you can get the right types and the right amounts of your emulsifiers to get the actual type of emulsion that you want. All right, enough of that. Now, in the podcast that probably nobody watched, there's several different commonly used emulsifiers. The one that you're going to do today in the dry lab is going to be the spans and the tweens, okay? Because they're very convenient and easy to use, and the system for calculating how much that you need for each of those is actually pretty straightforward. Okay, so one thing before I get into the specific types is that one thing that you'll have to learn is that for most emulsions, you need to calculate how much total emulsifier, whether it's from a span or a tween or whatever product you're using as the emulsifier, the actual weight or amount of emulsifier needs to be calculated. And it's often somewhere between 2 to 5% weight per volume of your liquid emulsion. So for us in lab, we're going to go with 5% because no ranges for us. We're just going to pick 5%. So in our calculations here in a little bit, we're going to use 5% weight of the emulsifier per volume of our liquid emulsion. Okay. Now let's talk a little bit about the actual emulsifiers and the system that we use for calculating how much of each one we're going to use. This table, or these tables, I should say, are in the back of your packet. So if you flip through the written packet, not the very back page, but the second to the last page, you should come to these tables. Okay, so see if you can flip through there for that. There are two very distinct tables. Okay, so first of all, let's define the way we're going to pick the amounts of each one of these are based off of their HLB value. So what does HLB stand for? Hydrophile, meaning they like water. Lipophile, meaning they like lipids. Balance, meaning how much do they like the water versus how much do they like the lipid on the scale. If they really like the water, then you're going to be high on the scale because this balance, this HLB value, ranges from 0 to 20. So somewhere between 0 and 20, we give a value for these emulsifiers. The higher the number, think about H is the first letter in HLB. So the higher the number, the more H it likes. So the more water-loving, hydrophilic it is. The lower the number, the more L it is, the more the lipid loving. Okay, lower numbers, lipid, L. Okay, higher numbers, water, hydro is the way to try to remember these values. Okay, so hydrophile, lipophile, balance. Higher you go, more water, lower you go, more lipid. So we assign a number between 0 and 20 to the different types of emulsifiers. And the spans and tweens were specific examples of chemicals that were formulated and modified in slightly. So there's span 20, span 40, span 80. Okay, so you can see all the different spans listed here. How do they differ? Well, let me hit my little light button here. They differ by the degree. So span 20s have a higher HLB value than a span 80. Okay, so again, different ranges of HLB values within the spans, okay? But spans in general, which would you say? They tend to have a lower HLB value, so the spans are the ones that are going to be more the lipid-loving type of emulsifier, whereas the tweens that we're going to be using here, and you can see the tweens here, have much higher values, okay? So they're going to be more of the water-loving. And it's the combination, because you can't just love water and ignore your oil. You need a little bit of oil loving, you need a little bit of water loving. The relative amounts depend on then the specific emulsion. So that's where this table over here gets to be very important, because this is our target. So while you can see we have HLB values for specific emulsifiers, now we can say, okay, what is a target HLB value? What combinations, when we add those two things together, or you'll see the calculations when we mix those together, what target final HLB value should we have? Well, it depends on your ingredient, what you're trying to emulsify. So you see a lot of list of ingredients here, okay? So let's look, for example, in our video, we had castor oil, right? So if we wanted to flavor castor oil for those poor children, then would we want to put the oil in the cherry syrup, or would we want to put the cherry syrup in the oil? Well, we want the oil in the cherry syrup. So that would be an oil in water. So if you look on this part of the table, we want an oil in water. And for castor oil, our target would be 14. So we'll go through and practice this with our actual dry lab. Our numbers will be different for the real dry lab, but this shows you the reasons you need both of these tables is you find the HLB value for your specific emulsifier ingredients, and you need one that's lipid loving and one that's water loving, but there are ranges you could choose within those. Once you have those, you're going to do some calculations to figure their relative amounts so that you can get the target amount of HLB, which is dependent on what your product is that you're trying to emulsify and whether you're making a water and oil or an oil and water. That will depend on how we do that. So that's kind of where we're going with the HLB values. This is important to define, and we'll practice here in a minute. All right, last couple of things to know about emulsions is that how much are you going to prepare? Do you have to prepare excess? And again, you can make emulsions using a mortar and pestle. That's a very common way of doing it. In fact, there's a special one that they use called a Wedgwood mortar that's really kind of roughened on the inside, so it helps you really generate even more force when you try to mix your and make your emulsions form. Yeah, you can do that. They're kind of a pain, and you do that a lot of times with topicals emulsions. But for oral emulsions, since we're probably going to dispense it in a bottle anyways, why don't we just make it in the bottle? So you're going to see today here, Dr. Wu's going to come in here. We're going to do the bottle method. We're going to add all of our ingredients in the bottle. We're going to cap it and shake it like crazy. And that's going to make our emulsion in the actual bottle we're going to dispense it in. Because we're doing that, there is no loss when we just make it in the bottle we dispense it in. So we do not need to calculate excess today, because not because it's an emulsion, but because it's an emulsion being prepared in the bottle or using the bottle method. So because of that, we do not need to calculate for excess. All right. So, well, that's kind of enough of an intro-y part. Let's jump into actually doing the dry lab. So get your calculators out. There's a fair amount of calculations in this preparation. Okay, so reading and interpreting it as you finish up. So the therapeutic oil, mineral oil, the laxative, we want to mix in cherry syrup. And we're going to put 30 mils into a total volume of 60 mils. So half the volume essentially will be mineral oil. The other half will be either cherry syrup or the volume occupied by the emulsifiers. The two emulsifiers were specified on the prescription. We're going to add SPAN 20, the lipid-loving one, with tween 80, the water-loving one. So that combination of those two, it doesn't tell us how much to use those. So we're going to have to figure that out. But between SPAN 20 and tween 80, we're going to have enough emulsifiers so that that mineral oil forms an oil in water emulsion and is flavored. Okay? So on the additional information, I'll just remind you, we have to kind of know, well, how much total emulsifiers do we need? And we're going to say 5%. So we're going to base our emulsifiers on 5%. Since we're using the bottle method, we do not need to worry about calculating for any excess. Okay. So, and just to be clear, and as we go forward on the calculations here, what are our ingredients? Again, we have mineral oil, which we said that's a liquid. So we have a liquid there. We have a liquid there for the cherry syrup. And then our emulsifiers we're going to add together. Okay, but realize this, the emulsifiers are actually liquids. So the SPAN 20 and the tween 80 are also going to be liquids. All right, that doesn't, we're going to measure them by volume, but they are liquids. And we'll talk about that here in a little bit. But we're going to basically have 4 liquids we're going to be adding together, shaking up and making an emulsion. All right, so let's start with the calculations. First thing is, let's use those tables. And I know you can hopefully maybe see this on the screen, but use the tables that you have in your packet. And the first thing I want you to do is, now we're talking about mineral oil, and we want to make an oil in water. So what is the target HLB value? What do we want to get to when we add our spans and tweens together? They need to be added up so that we get a total of, or a target of, what HLB value. So use your table and see if you can figure that out. Not rocket science. I'll let you have a second or two before I jump in. Looking on this now, here's my mineral oil. And remember, there's 2 numbers listed here, but be careful. I want an oil in water. I want that mineral oil dispersed in my cherry syrup. So my target is going to be 12. So what you should have for your target HLB value there will be 12. All right. Easy breezy. Let's go on and find the actual HLB values for our specific emulsifiers. We have SPAN 20. So let's go down. Let's see. Here's SPAN 20. And so there's its HLB value is 8.6. And we also have tween 80. So there's my tween 80 there. And that's a 15. So I'll write that down. And that should make sense that my tween with the W water loving is going to have a higher HLB value than my SPAN, which is going to be my more lipid loving. But I've got my 3 numbers there. Okay, right out of the tables. We'll use those here in a minute. But before we do, there's one other thing we need to calculate, which is simply the total amount of emulsifiers. Whether it's SPAN or tween, we don't care. When you add all those together, how much total emulsifier do we need? Well, we said that was based off of the 5% weight per volume. So go ahead and calculate that out. 5% weight per volume would mean 5 grams of emulsifiers for every 100 milliliters of emulsion, right? So That's my concentration. What is the total volume that we're trying to emulsify? We want a total volume of 60 milliliters. So what is 60 milliliters times 5% or times 5 divided by 100? I got, and again, milliliters will cancel. So I got 3 with my terrible handwriting, grams, 3 grams total. So my spans and my tweens total will be 3 grams. What I now need to know, and what we're going to calculate next, is how much of that is going to be span 20 and how much of that is going to be tween 80 of the total of 3 grams. Okay. So there are 2 ways of doing these calculations. Let's start with the algebraic way. Okay. So we're going to use algebra to try to solve this because, to be honest with you, we can treat the HLB like a concentration. Okay. It's not a concentration, but we can use algebra and this whole idea of mass 1 plus mass 2 equals mass 3 works for HLB to substitute for a concentration. So let's set this up. So let's do our CQ for the final product. So substituting for C, I'm going to actually, and I'll put E for emulsion. What is the HLB value in place of C for we want for the final product? What did we say the final product HLB value needs to be? We said 12, right? That's where we want to be in the end. We want it to be 12, okay? What is the quantity we're going to have of the total emulsion? How much emulsion will we have total when we've made everything? Emulsifiers, not emulsion, I say emulsifiers, but all of the emulsifiers together, we just calculated it. The total of both of those will be 3 grams. So we know that our final product needs to have 3 grams total of emulsifiers plus, or times, if you will, the 12 HLB value, okay? So let's do each of our ingredients. So let's do, what is the concentration, if you will, of our span? I'll put a little S there for the span. Well, we said the span HLB value was 8.6, right? So there's the 8.6. Well, what is the quantity of that span? We don't know. That's what we're trying to figure out. So if we don't know it, let's put in an X, all right? And it would be X grams. So of my 8.6 span 20, I don't know how many grams of that I need. I know the HLB will be 8.6. Bear with me on this. Let's do the last ingredient. What is the concentration, if you will, the HLB for the tween? Well, we said that's going to be 15. That came from the table. This is the hardest part to this algebra part, so bear with me on this. What will the quantity be? Once again, we don't know it, but do we know it in relationship to the total and the amount of the span? Yes, if the total of both will be 3 and the span is X, then what is the tween going to be? Tween is going to be 3 grams minus X. That will be the difference. So as long as you can see that the amount total is 3 grams, the amount of the span is X, and the amount of the tween is 3 minus X, then we only have one variable and we can set up our formula because we know mass 1 plus mass 2 equals mass 3, okay? And so this one is essentially the mass 3, that's the mass 1, that's the mass 2, okay? So go ahead, I'll give you a second to see if you can figure it out. So I'll work it out here in a minute, but if you can see that algebraic setup, practice your algebra, see how you do it. And essentially you're solving for X, and X will be the weight in grams of your span 20. Oh, my lights are turning off. I'm rounding to 1 decimal point there. Did you get 1.4? Yeah, we sure on this classroom. I can see if you did or not, but hopefully you got 8.6 times X gives you 8.6X. Add to that 15 times 3 is 45, but you subtract 15X and equals 3 times 12, which is 36. You do all that rearranging and you get 1.4 grams, hopefully, for X, and X is equal to the weight of your span 20, and that is the weight of your span 20. So for the required weight of tween 80, that's pretty straightforward, right? We said that's equal to 3 grams minus X. So what is 3 grams minus the 1.4 grams for the tween, I'm sorry, for the span, and you should get 1.6 grams for the weight of the tween 80. Everyone okay with that? 1.4 grams of span 20, 1.6 grams of tween 80. Now, that's all correct, and so we're not changing any numbers here on you. But, you know, that's a lot of algebra, and that's awful late in the semester to be messing with you with all that algebra stuff. So can anyone tell me, which I know you can't because I'm in a different room, but how else could you solve this equation without any algebra, right? Now you gotta admit, I'm a calculations teacher, I gotta do this. There was a way of doing that with no algebra whatsoever. I just want to do it quickly and kind of show you. It's awesome. I love it. It's with a word, not the A word you call me, another A word, not the aliquot. I didn't mean to bring that up. That brings up some trauma for some of you. So not an aliquot. It was an allegation. Let's do this visually with an allegation. And I'll do it quick because it'll give us the same numbers. But remember, with an allegation, you can put the high number on top. So remember, my high HLB value is 15 for my tween. So that's going to be my tween over here. My span was 8.6, right? So there's my little one. My target was 12. So watch, all I have to do is my little diagonal arrows. Do you remember the little diagonal arrows? Cross subtract. So 15 minus 12 is 3. 12 minus 8.6 is 3.6. Remember, that represents parts, so all you have to do is divide that by the combination of the two. So 3 plus 3.6 is 6.6. And that goes underneath each of those, all right? So now just multiply that fraction by how much do you want to have total? We want a total of 3 grams, right? So do this real quick. Just try those fractions and see what you get. So what is 3.6 divided by 6.6 times 3? What is 3 divided by 6.6 times 3? And let's see what you get. And let's see if you get the same number. So this should be 1.6 grams. That should be 1.4 grams. And remember, this number stays up here with this top number. So that would be your tween. That would be your span. So there are algebra lovers and there's allegation lovers. And there are some of us that love everything. So either way that you do that is fine. But would you agree, once you kind of know how to do that math, you're going to see here in a second, we've really done all of our calculations now. Now they took a little bit of time to figure that out. The actual preparation of this emulsion is a piece of cake. And you're going to see Judy do that here in a minute. So let's just fill out our compounding record though. So let's be clear on that. So under mineral oil, what are we going to use? Our target amount we said was 30 milliliters. And since it's a liquid, we can have that be our actual amount. Okay. We said our span 20 is going to be 1.4 grams. Our tween 80 is going to be 1.6 grams. And my cherry syrup, be careful here with the cherry syrup. It's going to be close to 30 milliliters because we want a total of 60, but there's going to be some volume occupied by those emulsifiers. And I'll never know exactly what that is. So let's do this. I'm going to put a QS 30 mLs because the amount I'm going to QS up to is 60 mils, but the amount of actual cherry syrup will be some amount up to no more than 30 milliliters. It'll be close, but not quite 30 milliliters. And the last thing before Dr. Wu comes in, as I said, the spans and the tweens are liquids. So you could go to an effort to find their specific gravities and try to convert their weights to a volume and measure them volumetrically. That is definitely one thing you can do. What we wanted to show you is how you can actually weigh liquids. So we are going to actually measure and determine and obtain the amount of the spans and tweens we need, even though they're liquid. We are going to obtain them by weight. So you can kind of see how we do that. So with that, Dr. Wu can come on in and you can kind of read the procedure as we go along, and I will try to get things set up for her to demonstrate the procedure for us. All right, I think we got everything up and ready to go.
Okay, all right, so I have everything here that we need. We will start with mineral oil. Before we start, I want to say that this is probably one of my favorite dosage forms because I don't even need any equipment. The only equipment I need is the bottle itself. All right, so we will transfer 30 ml of mineral oil directly into the bottle. And watch me, I am going to bend myself because I want to make sure that I can measure accurately.
So just pointing out, there are graduated marks on the bottle, and so you can use those so long as you are measuring to exactly one of those marks. You can't estimate between a mark on a prescription bottle, but each of those actual markings are considered accurate. So
even though that I said that this is really cool because you don't need any equipment, but you will see that what the problem here is that when we try to do addition of the emulsifier, we're going to add them into the bottle directly. So this is,
you want to compare the spans and the tweens and see which one if they can figure which is which. So which one, remember we said the spans are the more lipophilic, more oily, kind of greasy, if you will, where spans are more water loving. They're going to be more water loving. So even kind of flip them back, see if we can see the air bubbles move, tilt them a little bit back and forth. So which one is which, Judy?
this one is the more hydrophilic one. So this one is the tween and this one is the span. This one definitely looks more oil looking and this one is more water looking. So we're going to start one by one. We're going to add tween 80 first. And what is my target weight here? Tween 80?
So the tween 80 was 1.6 grams. So
Alright.
before we do it, just explain what you did with the bottle and the terrain. I just want to remind everyone on that.
Right, so I am going to measure 1.6 of this directly. So I'm going to place the bottle. Usually when I place a wayboard there, because in case I spill, it's collecting the wayboards. And you want to pair that so we can measure the weight out of this liquid directly. So as Larry said that you can measure liquid by volume, but there's also another way to measure liquid by weight. Okay, so we're going to add it here. Okay, the key thing here is you don't want to have extra. Because if you, so I want to start a little quicker and then I want to definitely slow down. Right now, can they see the number?
Well, they can see the number, yes.
Okay.
It's hard to show the tip and the number at the same time.
All right, as I said, the major issue with this method is if you overshoot, you have to restart over again. So that's why by this time I'm getting really close. Maybe I would add a little tip there. Okay.
That is excellent. That is perfect. So go ahead and write down as the actual for the tween of 1.6 grams. I'd call that 1.6 exactly. So there we have that. Now this is an important part to this step though.
Don't forget to tare before you move on to my balance is not working properly today. Let me click one more time.
A little breezy.
Stop reading there.
Yeah. Stop talking. That was what they really want me to do.
Okay, all right. So now let's go ahead and add a tween, and then this will be 1.4 grams. Now this one, the addition will be a bit harder because it's very, very viscous. So I have to push really hard to get it out. So again, I will try to do relatively quicker to start with. And this is me pushing like really hard already, and it's really coming out as like a drop of ice.
As a reminder, it's certainly a way to do it, but as Judy emphasized again, if you go over, if you add too much, there's no undoing that. You have to start all over again. So no pressure on Dr. Wu here, but this is definitely a quick and easy way of doing it, but it does require precision to get our 1.4 grams as close to possible without going too far over.
Okay, we're almost there. Bear with me, 1.2. Okay, we're getting really close. Okay, excellent.
Perfecto. So let's document 1.406 grams, 1.406 grams. So one quick thing before Dr. Wu finishes up on the procedure, there is a way to do this by measuring a liquid by weight without having to do it in the bottle. What you could have done is used a syringe to actually tear an empty syringe, pull up the liquid into the syringe and keep weighing the syringe until it's the right weight. That way she could always remove any extra until she gets the right weight and then squish that into the bottle. So you don't have to measure it into the bottle directly to avoid that potential concern, but this is definitely a quicker, easier way if you're careful.
Okay, all right, so we are ready to add the sherry syrup, but before we do that though, because I have oil and a lot of surfactants in there already, so I want to shake really well first, so that all the oil will have a good mixture with the surfactants.
Dr. Wu, why did you start with the mineral oil and not the cherry syrup?
That's excellent question. I need to think about that which phase I want my oil be in. In this case, I want to cover the flavor of the oil. So I wanted the oil to be inside. Therefore, I want to start with the oil.
So a key trick, if there would have been a test on this, is to know that you start with the internal phase and add the emulsifiers to the internal phase, and then add the external phase last.
All right, finally, we can add in the yummy stuff. So the flavor reagent with the cherry flavor. All right, so again, as you can see here, that I'm bending myself again, because I want to make sure that I'm adding to the right volume. And we are QS to 60 mil. Excellent. All right, this is not quite ready yet though, because it's not quite emulsified at this time. Can they see well?
Yes, I think you can see there's kind of a clear phase on the bottom and a little bit of a cloudier phase on top. So as we said, the oil and the water themselves don't just generally mix.
All right, so what should we do then? Go ahead and mix really hard one more time. And at this point, if you look one more time, you shouldn't see the separation of those two layers anymore. It's uniform now.
So let's finish up at the QA, Dr. Wood. Tell us exactly, carefully look on there, and let's leave it on here so they'll be able to see it.
Oh, okay.
What is the, so the QA volume, what is the final volume on there?
The final volume is 60 mils.
So 60 mils under your QA final volume, and now she'll pour some out into the weigh boat, and we will describe the final product.
Let's take a look.
Ooh.
You did a really good job.
Ah, that is an excellent job. So, would you agree? And let's see, I don't know how well you can see. I'll zoom in a little bit. Let's describe this. Remember, in our crazy way, let's put a color to that. Thank you, Dr. Wu. What color is that? Let's call that pink. So it is a pink. This is under visual description. It is a pink. Let's take a big whiff of it. I just smelled it and I didn't smell anything. So what is our term? So when you don't smell anything, let's call it odorless. So it's a pink, odorless. Would you agree, is that clear? Because the ingredients were clear to begin with, but it's not clear. That is definitely opaque, okay? Why is it no longer clear? We started with two clear liquids. The cherry syrup is, again, it's not colorless, but it's clear, and the mineral oil was clear. Why is it cloudy? Because you have the mineral oil in the form of really small droplets. Droplets you can't really see, even though what you can maybe see there are some air bubbles, but you can't see the droplets of the oil separate, but that's what's making it cloudy, okay? So the opaque, okay? So it's so we said it's a light pink or a pink, odorless, opaque emulsion with no visible droplets. Okay, we're looking here, I don't see any visible droplets. And then lastly, you'd want to describe it as easily redispersible. So pink, odorless, opaque emulsion with no visible droplets that is easily redispersible. Because, and let me go ahead and we'll go back to the screen share here. Come on. All right, hopefully we're back on there and you can kind of see that description there. So we have, as Dr. Wu did, she shook really vigorously to mix the oil and the emulsifiers and the external phase, the cherry syrup together and disperse those droplets. They will not remain dispersed. They will separate over time. The term used for this normal separation of emulsifiers over time would be creaming. So the creaming of an emulsion is when they separate normally. So, okay, so let's finish up on a couple of things relating to the quality control. We talked about easily redispersed because it will separate. So as Dr. Wu talked about, you're gonna need to shake this up every time. So we're gonna wanna put a shake well label on this every time. That separation, phase separation is normal and it's called creaming. So an emulsion creams as it separates. The problem is that when it creams and separates, you don't want it to stay separated. And if you can't shake it and it doesn't go back to a nice homogeneous mixture, then that's called cracking. Your emulsion has cracked, okay? So we don't want our emulsion to be cracked. We want it to be easily redispersed. So that's why we added that part to it as well, okay? So that's enough with the quality control. Beyond use date here is, be honest with you, the same to some extent as the emulsions that the creams and ointments we talked about. If there wasn't any water in it, it could be 90 days, but clearly there's going to be a water in an emulsion phase. So it's not the 90-day thing. it's either 35 days or 14 days. And if you remember, the difference between 35 days and 14 days is whether or not the final product is adequately preserved. Does it have an adequate concentration of preservatives to prevent microbial growth? And in this case here, there were preservatives in the cherry syrup, but there were not in the mineral oil, and there isn't in the spans in the tween. So we definitely took a preserved cherry syrup, and now we have no idea what the effective preservative concentration is now that we've mixed everything together. So we cannot assume that it is correctly preserved without adding separate preservatives. And since we're not going to do that, we can't go with the 35 days. We're going to have to go with only 14 days. So the correct beyond use date for a non-effectively preserved water-containing product is 14 days and under refrigeration. So under storage, that goes together. So our 14 days from today, and we would put it in a refrigerator and then an oversized bottle, because just like suspensions, you need room to shake it up really well each time. So there you have it. That's kind of the information on that. Drug labeling, as far as the drug name goes, it's pretty straightforward. You need the active ingredient, in this case, mineral oil. That's really the only active ingredient. You need to express its amount. Since this is a liquid emulsion, let's express its amount per volume. So it's a 50% essentially volume per volume, right? Half of the volume is mineral oil. So we expressed it as a 50% volume per volume. But here's the deal. Do you need to put cherry syrup on the label? Well, when we did suspensions, we said, no, you didn't have to put it on the label. But here's the deal. This isn't just a mineral oil emulsion. The whole reason to making the emulsion is to flavor it. So that's why we called it a flavored. We didn't have to say cherry syrup specifically, but we wanted to indicate that it is flavored. So flavored, it's being used internally or orally. So we've got to specify that, because you can put emulsions in the eye, on the skin, lots of different places. This is an oral emulsion. And lastly, emulsion for the dosage form. So mineral oil, 50% volume per volume, flavored oral emulsion. There's the drug name. All right. Last two things to put for the auxiliary stickers would be shake well, for the reasons we talked about, and keep refrigerated, because it needs to be stored in the refrigerator and for the 14 days. Okay, pretty easy. That was essentially an emulsion, a liquid oral emulsion. Now, why didn't we have you guys make one as a part of your wet lab? They're too darn easy. Would you agree? All you have to do, if you don't mess up the first time, is put the internal phases, add your emulsifiers, add the external phase, and shake like crazy. That's really all there is. But it's the calculations to determine the relative amounts of the spans and the tweens are the most difficult. All right, so let's move on to topical gels, because that is what you're going to be making today, is a topical gel. All right, so a gel is a semi-solid, like a cream base or an ointment base. It's got some consistency to it, right? It's not a liquid, it's not a lotion. So it's got a jelly-like consistency is the best way to describe it. And you can put lots of molecules and drugs in this kind of jelly-like consistency. So remember, drugs themselves don't form gels. So you take your you take your drugs and you have to mix it with a gelling agent. So there are some chemicals that can form this jelly-like 3D structure that can hold your drugs on top of the skin, for example, where you want to put them. So let's talk about gelling agents, okay? So there are two different classifications, and this gets to be important. I know you're tired of listening to me already, but there are two types of gels: hydrogels and organogels, okay? A hydro, the word for hydro comes from water. So a hydrogel contains water and alcohol, because sometimes you have to use some alcohol to help dissolve the gelling agent. But remember, water and alcohol don't gel. It needs, in the water and the alcohol, you need a gelling agent. And the two to kind of remember is a very common one is called carbomer. So carbomer, and then Poloxamer. You're going to be using Poloxamer. The reason that it's worth remembering carbomer is, let's talk about a classic hydrogel that you're going to sell. What hydrogel are you going to sell a lot of this summer? Because people during the summer tend to spend too much time outdoors and they get sunburned. So what is a classic kind of clear gel that's got all these like bubbles in it that people put on sunburns? Can you think of it? Aloe vera. So think of an aloe vera gel. Now, I know sometimes they'll put in blue or green coloring just to make it look funny, but essentially a lot of times it's just this crystal clear, bubbly looking thick gel that's got some aloe vera in it. Well, what makes the gel is the carbomer, and that's a classic hydrogel. Water, alcohol, aloe vera, and then this carbomer mixed up to make this gel, okay? And that's an awesome gel. But think about it though, hold on. Where do we want the aloe vera to work? We want the aloe vera to work, if we rub it on a gel on the skin, we want it to stay on the skin. We're not trying to get it into the body to go somewhere else in the body. We're trying to put it right where it needs to go. So this hydrogel is thick enough and it just covers it up and it has a cooling sensation. Since it's got water on it, it works really well. But what about this? What about, and I'll use the example of your wet lab. So look on your wet lab prescription here. We'll talk through it here in a little bit, but it's actually for a cold sore. So somebody who's got a sore on their lip, okay? And cold sores are caused by viruses. Well, when we put the cold sore medicine, we don't want it to stay on the outside of the cold sore. We want it to get into the cold sore to get rid of the virus. So how can you put a drug in a gel that doesn't keep it just on the outside of the skin, but helps it actually get onto the inside of the skin? Well, what you can do is you can take a hydrogel and mix it with a skin modifier. And the one that you're going to be using today, because you are going to be making an organogel, is you're going to take a hydrogel and you're going to mix it with this chemical called LIPS. Favorite drug name ever. LIPS stands for lecithin isopropyl palmitate solution, LIPS. It's brown, it's oily, it's greasy. So it is the lipid part that you're going to mix with the hydrogel part, okay? And what you make when you mix hydro with lipid, you get an emulsion. So you are going to be making a micro emulsion today. You're going to get the lipid to disperse around inside the organogel, okay? Or I'm sorry, in the hydrogel. Why add the lips? Because the lips softens up the skin. It's a skin modifier that enhances absorption. So if you actually want your drug in your gel to penetrate through the skin and be absorbed into the body, even if it's just locally, then you want to add a skin modifier like lips. And that takes your hydrogel and makes it what we call an organogel. So an organogel is a gel that contains a skin modifier like lips to enhance drug absorption. And there's a lot of these coming on the market now. I don't know if you've heard of Voltaren gel or diclofenac gel or naproxen gel, topical gels. These are medicines that have anti-inflammatory medicines that people put on for arthritis. Think a lot of times you take ibuprofen, you take naproxen or even diclofenac by mouth, goes all through your body to work in the joints. Well, you can avoid a lot of the stomach side effects and some of the other side effects if you can just put the drug directly on your knee or on your ankle, wherever it's hurting, and get the drug to be absorbed more locally. You can produce the effects without maybe some of the side effects. So those gels are all gels, though, that have the skin modifier to help enhance absorption. So in the end, when the gel that you're going to make is going to have lips, so it's an organogel, the gelling agent, but lips is not a gelling agent. Lips is a skin modifier. So how do you make the gel? The gel you're going to be using is going to be using Poloxamer. So Poloxamer, P, plus lips, L, to make an organogel, O, is why you're making a PLO gel. PLO stands for pluronic lecithin organogel. And that's what you're making, all right? Now, why did we choose to use pluronic or Poloxamer instead of carbomer? Poloxamer is more awesomer. That's why, and I even recorded that word. Why is it awesome? Because it's a liquid already. The carbomer comes as a solid, and I don't know, no one watched the video, but truly, to deal with carbomer, you have to heat the water really hot, and then you have to sift it in slowly because this carbomer is kind of like a wax, and so you have to melt the wax, but you don't want it to clump together, and it takes forever. Now, for the Poloxamer, it actually comes as a 20% solution. So the liquid you're going to be sucking up into your syringe is already a 20% solution. You don't have to worry about that, but that solution of Poloxamer is a liquid, which makes it really easy to work with. Well, let me ask you this. If it's a liquid, how is it a gel? We don't want a liquid in the end. We want a gel in the end. And the gelling agent is the Poloxamer. So how can a liquid be a gelling agent? Because it's liquid only when it's cold. Poloxamer 20% forms a thermoreversible gel, meaning at cold temperatures, it's a liquid. So right now, it's the only ingredient I haven't set out. It's still in the refrigerator. First thing I'll do when I finally stop talking was to go get it out of the fridge because I have to keep it cold to make it a liquid so that you can use it. However, when you start to use it and you squish it back and forth between these syringes, we'll talk about here in a minute, and it comes to room temperature, then it becomes a semi-solid. That's when it starts to gel. So your final product will be a gel after your ingredients have been mixed and allowed to come to room temperature, because the gelling agent is thermoreversible and is a gel at room temperature. What do you think the worst thing you could do to a thermoreversible gel is when you get it dispensed after you've made it? To put it back in the refrigerator. If you put your final product back in the refrigerator, what would it do? It would liquefy. Remember, when the gelling agent gets cold, it turns into a liquid. So after we use it, we never want to put it back in the refrigerator. That would cause a huge problem, okay? So keep that in mind. Last thing, okay, thank you for putting through with the classifications there. The amount to prepare, you're going to see here in your procedure, you're going to be mixing these things in syringes back and forth and back and forth. And so it's kind of like the bottle method. You're making it in the actual things you're going to kind of dispense it in. So we're not going to calculate for any loss. If you were to make the same sort of gel in a mortar with a pestle, and then you would have loss, you would definitely calculate for excess. But we'll do our calculations together here, but you're not going to calculate for any excess because of the method we're going to use to compound it. All right. All right. Finally, since I know none of you want to have to be here longer than you have to, so let's work on these calculations together. I think you're going to find that they're pretty easy, and even the procedure is really quick. So this is not a difficult thing to make, and it's kind of fun to do. So let's do the calculations together. Let's read and interpret it. So in this case, we have a prescription for Don Wright, and this is, as I mentioned, is for a cold sore on his lip. Since cold sores are caused by viruses, let's put some acyclovir in there. And I know that was probably on your top drugs exam at some point. So acyclovir antiviral drug. We want it to be 1%, essentially weight per volume. Since we're dispensing it by volume by 10 mils, that's 1% weight per volume. We also want lidocaine. Lidocaine is a topical anesthetic. It'll kind of numb and kind of take away some of the pain as we get rid of the virus. So we want it to be 2% weight per volume lidocaine. All right. Then we're going to want 25% of the volume to be lips, this lecithin isopropyl palmitate solution. And since lips is a liquid, that percentage by default is volume per volume. So we want 25% volume per volume to be lips. And then whatever is left over, whatever volume remains, is going to be our Poloxamer. We don't need to worry about the 20%. We're going to be using the 20% solution. So the question is the remaining volume of the 20% solution. So don't worry about that 20% in our calculations here in a minute. Okay, so essentially 4 ingredients being combined together. All right, look under the additional information. We're not going to base our calculations on any excess. And here's the deal. Our acyclovir is going to be a powder. So it's a solid. Acyclovir is a solid. The lidocaine source that we're going to be using here and calculate for is a liquid. It's an injectable. So it turns out we're going to be able to dissolve our acyclovir in whatever volume of lidocaine we calculate because it is freely soluble. So just keep that in mind as we go. So let's do our calculations. So see if you can jump ahead of me just a little bit here, and let's calculate the amount of acyclovir powder. Now don't calculate for any excess. So if we want it to be 1% weight per volume and we're going to prepare 10 milliliters, calculate how much acyclovir we need. Did you get 0.1 grams? Keeping our units careful. 10 milliliters times 1 gram over 100 mil. That said milliliters there. Sorry, milliliters, and we get 0.1 grams. Okay, that should be pretty straightforward. Now let's calculate the lidocaine. To understand this, what you need to know is our source of lidocaine, as I said, was an injectable, and it actually has a concentration of 20% weight per volume. So our source, our ingredient is lidocaine, 20% weight per volume. We want to know how much of that we need to have our final product be 2% weight per volume. So you can do this a couple of different ways. Let's do our CQ equals CQ because it's a dilution, right? So what are we starting with? Well, our concentration of our injectable is 20%, right? So we're starting with 20%. That's its concentration. How much of that are we going to use? I don't know. So I'm going to put an X there, some unknown milliliters. I'll put milliliters just to be consistent. Some unknown volume of that 20%. And what I want in the end, though, is to make a final concentration that's 2%. So put 2%. And what will the final volume of all of my stuff be? Well, that's going to be 10 milliliters. I know that. So now solve for X. See what you get. What is your volume of this 20% lidocaine that would give you a 2% concentration when you make 10 milliliters? I get 1 milliliter. Okay, so 1 milliliter of this 20% solution. When you mix it with everything else and get a total volume of 10 milliliters, we'll make that final volume have a 2% concentration. Okay, did we get to 1 milliliter okay? All right, let's keep going. They're not any more difficult than this. So we said the lips is a 25% volume per volume. So tell me how many mils of lips do we need? No, not 2.5. So I got 10 milliliters of my gel times times 25 milliliters of lips per 100 milliliters of gel. That gives me a total of 2.5 milliliters of my gel. Lips, sorry, of lips, 2.5 milliliters of lips. I'm starting to lose it. All right, because I'm so excited to get to the last calculation, which is the Poloxamer, which is simply the remainder when you subtract all the other volumes. So let's start with this. So what is the total volume? Is 10 milliliters. From that, let's subtract. Now, wait a minute. What about subtracting? Do we have to subtract the acyclovir? Well, acyclovir has weight, but we're going to dissolve it in the volume of the lidocaine. So it won't really have a significant amount. It's a pretty small amount. Trust me on this for now. There won't be any significant change in volume by dissolving the acyclovir in the lidocaine. So what was the volume of the lidocaine? We said 1 milliliter. So I'm going to subtract 1 milliliter for the lidocaine. Then I'm also then going to subtract 2.5 milliliters for the lips. So subtract all of that, and what do you get? When you do all of that, you should get 6.5 milliliters of the Poloxamer. There you have it. So in your compounding record, since we've already done these things about, you're going to have 0.1 grams of acyclovir powder, 1 milliliter of lidocaine 20% solution, 2.5 milliliters of lips, 6.5 milliliters of your Poloxamer solution. Okay, so that's pretty much all of your amounts that you're going to do. So let me point out a couple of things. First of all, go to look through in your packet, go to the very last page. So if you go to the very last page, it should say, it's kind of a thicker packet, right? So the very last page says quality assurance. So the very last page of your packet says quality assurance of the PLO gel. Put a bit of X through that, you're not doing that. So you don't have to worry about the quality assurance worksheet. But the second to the last page, you do need to do, and that's what I'm showing you on the slides here, where it says worksheet calibration of dispensing pen, because you are going to dispense your final product today, not in the syringe. You're going to transfer it to a dispensing pen. Why? Because it's cool. You'll see why. It's kind of a neat little dispensing device. So, but part of what I want you to do is when you use that dispensing pen, you need to calibrate the volume of each little squirt it puts out. So to do that, you'll notice step 1 and step 2 is the biggest thing here. I'm going to talk about the procedure back here in a minute, but you have to write the weight of a syringe, an empty syringe, and then you have to write the weight of that same syringe when it's filled with all your product. So step 1 and step 2 are some very important things you have to fill out during the procedure. So I thought I'd point that out. Now, if you want to go back to the procedure, okay, some things I'll let me try to show you. If you're in the classroom, this would be so much easier. I want to point out, this is pretty easy, but I don't know any of you really prepared too hard for today. So I want to, let me see, I shouldn't have done that. Let me stop my share here, and I want to bring up the video that I hope some of you got a chance to watch. If you did, it's going to make this really easy. But let me, again, share something else, share sound, all this. Okay, so hopefully you can see this little video. So here you'll see on the left-hand side of the video here, you can see the AccuPen. That's your final dispensing pen. It's got a kind of a long tube. It's basically a funny shaped ointment jar. And it's an ointment jar though that you're gonna make an air cap seal. So this kind of red cap makes an airtight seal. And then this button here allows you to push down on the top to push out a little squirt out the bottom. So that's your AccuPen. Then we're going to have 2 syringes, and actually a total of 3 syringes. So let me explain first. So the first thing you're going to need to do, to be honest with you, is weigh out some acyclovir powder, okay? However, the acyclovir powder is just like the urea was. When you get it, it's going to be very crystalline, and it's going to be kind of granular. So you're going to want to grind it up. So just like you did with the urea before, and again, you don't need a whole lot. 0.1 grams is not more than 1 or 2 scoops of your scoopula. So it's not a lot of powder. So get 2 scoops, if you will, go back to your mortar, grind it or triturate it really fine, and then weigh out your final amount. Okay, so you do want to make sure that you're using finely triturated acyclovir powder. Trust me, otherwise it will not dissolve on you. You want to grind it up first. So you're going to grind up and then weigh out the amount of acyclovir powder that you want. Okay, Then you're going to put the acyclovir powder into, this is important, your smallest glass conical. So we do not want a tall one. We don't want the big 4 ounce. You should have a 2 ounce small glass conical, not the cylinder, but a conical. You can tell you're going to put the powder on the very bottom. So that's where your acyclovir powder is going to go. You're then going to go measure your lidocaine solution. And remember, it was 1 milliliter. All right. Now, because I didn't want you guys leaking with the injectable, I've gone ahead and opened up the injectable bottle here and actually just poured it out. So this is just in one of my plastic containers. So just take off the green lid and you're going to then suck up 1 milliliter. To do that, you're going to use a 3 milliliter syringe. So that's what the 3 milliliter syringes are there for. You also are going to go ahead and attach a needle. There is a longer blunt end needle. So attach that needle to the 3 mil syringe and use that to suck up the 1 milliliter of lidocaine solution. Okay. Don't throw that syringe away. We're going to need that here in a minute, but be aware. So you're going to use the 3 mil syringe, attach a needle, and you'll suck up out of the bottle your lidocaine. Now, with your 1 mil of lidocaine here, you can see you're going to carefully pour it and squeeze it directly onto the acyclovir that's in the small glass conical. You're then going to use a glass stir rod and stir, 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 and dissolve that acyclovir within that 1 milliliter of lidocaine. Now, it doesn't go in solution right away. It takes some time, and it really takes time if you don't grind it up first. So grind it up first, put it in there, mix it with the 1 mil lidocaine, and give it a little bit, and it will start to dissolve. While it is dissolving, you're going to stop, let it sit for a little bit, and go prepare your lips and your pleuronic. So realize you want to get this step started and then go get your lips and pleuronic. Okay, and eventually it will dissolve, as you can see, and be in there in the thing. All right. So I'll skip this step for now. So while it's dissolving, you're going to go get your Poloxamer. So that's the clear. Remember, Poloxamer is the gelling agent. It's the hydrogel, the water alcohol mixture with the gelling agent. You're going to use a 10 milliliter syringe, and you're going to pull up. Do you remember how much for your Poloxamer? 6.5 milliliters. So one of your 10 milliliter syringes is going to have 6.5 milliliters of the clear gelling agent, Poloxamer. Okay. You're then going to go get another 10 mil syringe and pull up 2.5 milliliters of your lips, okay, which is essentially that oil, okay? So 2.5 milliliters of lips in another 10 mil syringe. So you'll have those 2 syringes. What now? So the point being then, by then, you will have dissolved your solution. So again, your lidocaine acyclovir will be dissolved. Take your 3 mil syringe with that needle that you didn't throw away, set it aside. You're going to then use it, and you need that long needle on there so you can put it back into the conical and suck it all out. So you're going to suck out that 1 milliliter of lidocaine acyclovir solution back into that 3 milliliter syringe. Okay, so that's what she's doing now. So essentially then we're at this stage. You've got all 3 syringes. Where you're going to start is by combining your clear lidocaine solution with the acyclovir with the clear Poloxamer. You see where these are both clear, okay? So how do you put the contents of one syringe into the other? Because you're putting the lidocaine into the Poloxamer. You'll see we have these red syringe tip connectors over there. You need one of these. They're not disposable, so don't throw it away. You need to put it back when you're done. But essentially, it has a luer tip connector for the syringes on both ends. So you just kind of twist and squeeze on, or twist on, the luer tip connector for both. So let's see and kind of see this example here.
Our Poloxamer solution, and this is the aqueous phase. We want to go ahead and our
Squeezing it off.
and then attach our 12 ml and luer lock that on to.
Okay, so we have twisted and connected the 3 ml syringe to the 10 milliliter Poloxamer containing syringe, okay? Now, which solution gets pushed where? We want to push the 1 milliliter into the Poloxamer, because if you push 6.5 milliliters of the Poloxamer into the 3 ml syringe, what do you think is going to happen? It's called a volcano, because you will squish the back of your plunger out and shoot it everywhere. Remember, you cannot put 6.5 mils into a 3 mil syringe. It will shoot out the back. And I know some of you are thinking, well, that might be more fun than normal, but don't do that, please. So remember, all you're doing here is transferring the 1 mil into the 10 milliliter syringe. Okay, we don't even have to mix it at this point. It's just a transfer. So you'll notice you will just kind of squish the plunger and it will be pushed into the Poloxamer syringe. At this point, you're going to unscrew and remove the 3 ml syringe. You want to leave the syringe tip connector on the Poloxamer syringe. All right. What you will want to do is then push any bubble out, because there may be a little bubble of air here when you remove that syringe, because we're going to then push a little bit of Poloxamer so that there is no bubble. Then you're going to get your lips syringe and you're going to screw it on just like we did before. So now you have 2 10 ml syringes, okay? So you can transfer the solutions back and forth without causing and creating a volcano because you have equal size syringes, all right? So now this is how you're gonna make your emulsion. You need to do this with energy and vigor. You need to be able to squish back and forth, and you're gonna need to do it at least 40 times. So let's watch her do this here.
And do it side to side.
Back and forth, and back and forth.
And you want to rapidly move the solution from one syringe to the other, or you can use the counter and push it and just rotate it.
Okay. How many times did I say you need to do that? 40 times, because it is important to make the mixture an emulsion. So you'll notice when it first starts off, they're both kind of clear. Now it ends up cloudy. Why? Because you made an emulsion. You'll notice at the beginning, there's these brown streaks of that lips oil. You need to go back and forth till you have a nice, bright yellow, melted butter looking emulsion. And trust me, you also need to get it to start to set out. Because remember, they're liquids when you start moving them back and forth, but you'll notice it gets a little bit harder to push the plungers in because it does tend to thicken up as that Poloxamer warms up and essentially starts to gel, which is what you want it to do. So you want the heat and the energy of that constant transfer back and forth to be able to do that, okay? So now, one thing I omitted to say. One of the first things you need to do on your procedure is to mark one of those 10 ml syringes, whether it's the syringe that you put the Poloxamer in or the syringe that you put the lips in, it doesn't matter. But before you do anything, use your Sharpie and mark it somewhere either on the lip of the plunger or on the barrel, somewhere that's not going to rub off with your fingers, and obtain the weight. So step 1, remember on that worksheet, was the weight of an empty syringe. So mark one of those syringes and write down the weight of that empty syringe. Because the reason that now, if you look on the video, we've mixed it back and forth, we want to eventually push all of the product back into that marked syringe. So whichever syringe you marked is when it's done mixing, you're going to put it back into that syringe, remove the tip connector, put it on the scale, and on your worksheet, write down the weight of a filled syringe. Because if you subtract those two, you should be determining the weight of your actual product. So keep in mind, when you're done mixing, be sure you transfer it back into the marked syringe so that you can determine the weight. The rest of this video has to do with then filling the AccuPen. So as we said, you're going to have all of the product into one of the syringes. You're going to then hold the AccuPen, and you want to hold it straight up and down, and you're then going to carefully squish all of your product into the bottom of that pen, okay? You're going to need to tap it, just like you did with the ointment jars. You're going to want to tap, 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 and carefully squirt and get as much of that into the very bottom. You don't want it dripping all the way down the sides on the inside. Get the gel at the very bottom of this long ointment jar, if you will, okay? Once you get all of that squished into there, then you're going to need to add the red cap. And the red cap, let's see here, I'll have her describe it.
So my finger can fit in that. Okay, once the gel is into the AccuPen, you need to go ahead and put the interface between the gel and the air. And this comes in 2 sides. One is an indented, so my finger can fit in that side. The other is like a button. So, and then place it gently. And what you're going to be doing is moving that interface down until it comes into contact with.
So you're pushing with your glass stir rod, and you push and then release. Push it a little harder and release. What'll happen is air will kind of squish out of it for a while, but it's going to go about partway down the container. It may not go all the way to the gel. Don't push it all the way to the gel, but you're pushing it down and pushing it down until it forms an airtight seal. And this is really important. You have to push in the middle of that red cap. If you push on the side, the cap will flip over in the middle of the pen and it's a goner. So push it carefully straight down until it starts to bounce back, to where if I push with any strength, it's resisting it and it kind of bounces it back. It just means it's made that airtight seal. So once you've made the airtight seal with the red cap, then you're going to put the white cap on.
And then you can go ahead and use the countertop till it clicks on.
So that outer cap is just pushed, and then you turn it upside down and push hard enough to where you hear that clicking sound. And that's essentially the lock and the button that will allow it to kind of squeeze out, because the whole point of this pen is
the gel from the top of the AccuPen. If you turn the button counterclockwise, that will go ahead and open for the gel to be dispensed. And to dispense the gel, you click it just like a pen, and you want to go ahead and prime this device to make sure there's no air in those first few squirts coming out. So go ahead and dispense some, and when you get one or two of the squirts that have no air in them.
So there you have it. You're going to unlock it. You're going to hold it straight up and down. It works a little better, and then squish with your thumb, and it's going to squirt out. Okay. The first couple of times there are going to be some air bubbles. They may not be consistent. So just squirt, squirt, squirt until you get nice consistent squirts to come out. All right. Now you got to go back to that worksheet. To finish up the worksheet at the end, you also have to determine the weight of 20 squirts. So to do that, you put a weigh boat onto your balance, hit tare, and then count out 20 squirts. And then you'll use the weight of those 20 squirts to calculate essentially the volume per squirt on that worksheet. So part of what you got to do is not only bring us over your completed AccuPen with your beautiful product in it, but your completed worksheet that you've also then determined and calculated the volume for each one of these squirts. And I'll be honest with you, you don't have to use an AccuPen. A lot of times when you make PLO gels, you might just dispense it to the patient in that syringe. But the problem with that is they have to look on those little bitty markings, and to be able to give themselves exactly 0.1 mils, they have to be able to read it and push it without overdoing it. So this is a potentially much more convenient way for a patient to be able to say, okay, to dose yourself, you're just going to need to put 3 squirts onto the affected area. So, and again, it'll be more consistent without the potential for overdose. So it's just a different way of dispensing this gel. So anyways, let me stop that. Sure, I think that's enough of the video. I'm not sure. Let me go back to here real quick. And let me go through a couple of things. All right, so that was the whole thing to the procedure and your worksheet there. Let's finish up real quick so we can be done with it, and you can just make it and then show us and then leave. So the finish for your documentation for your QA, you're going to want to put 10 milliliters. That's what you'll be making. Let's describe it now, and then you can determine whether that's really what it looks like when you're done. If you can see on the video, it was yellowish color. So it was a yellow or a tan. Okay, it was opaque. Remember, it's an emulsion, so it's not clear anymore. So it's cloudy. So you've got a yellowish tan, opaque, odorless, medium viscosity. Remember, a gel, we want it to gel. We don't want it to be liquid. So some description of the viscosity. It's not super thick. It's not like honey, but there's some viscosity to it. So it's a medium viscosity gel. But we clarify this at room temperature. It won't be medium viscosity if you put it in the fridge. It'll liquefy, okay? So there you have it. So 14 days, remember, we're not adding any extra preservatives. We got all these other ingredients in it. It definitely contains some water in the Poloxamer, which was a hydrogel. So we're gonna put 14 days beyond use date since we don't know about the preservatives. And again, this is super important. The storage would be room temperature. Do not refrigerate, okay? So there you have it. For the sake of the rest of this time, we'll talk about this for storage on the when you check out. So I did put the errors and omissions online if you want to play with this. I know you just want to do this. Thank you for putting up with me. So at this point, let's just make the product. So to get out of lab, you got to make the product, and you'll bring it over in your AccuPen after you've completed the worksheet. So we'll look at your worksheet, we'll look at your AccuPen and your product, and we will tell you to have an awesome semester and good luck on finals. We're almost done. So get out there and let's do it. Thanks for your patience.